Good. We'll get started in just a minute. All right, we're ready to go. Welcome to the Teradek webinar series. Thanks for joining us. We really appreciate it. My name is Mark Jeffrey, and I am on the marketing team here at Teradek. And we're really excited to bring you this webinar with our partner, Phenix. In this industry, we've come a long way from broadcast latency and scalability being the bar to a unicast internet distribution that lagged far behind, from real networks with a postage size stamped video at 6 frames a second to the ABR of today, throttling innovation and delivering video with poor quality, latency, and it wouldn't scale either. In the new world is driven by immediacy, driven by the internet, social media, instant access to data and content. At Teradek and Phenix, we're pushing the boundaries of immediacy, scalability with a value proposition that continues to push the envelope. Let me introduce the speakers for the webinar. From Teradek, Derek Nickell, Technical Product Manager, and from Phenix, Bill Wishon, Chief Product Officer, and Kyle Bank, Chief Operating Officer. Our agenda is to run through an overview of the products and services that make this possible, make it happen, provide a demo, and then circle back with a discussion around delivering video content with sub-second latency. On that note, I'll hand it over to Kyle.
Thanks, Mark. Really appreciate the intro. Really happy to be here with everyone. And Derek, if you want to pull up the slides here, we can start walking through this for everyone. Awesome. Derek, do you want to jump to the next slide? So thanks everyone for attending. We're here today to talk about the combination of Teradek and Phenix products, and together we're able to deliver ultra low latency, and that includes everything from encoding, production and real-time distribution to global audiences. You'll hear about how Teradek is really differentiated in terms of their encoding density and the various products and services that they offer, including cellular bonding to improve uplink into the cloud, as well as Phenix's ability to deliver sub-second latency at broadcast scale, one of the big things that differentiate, and we can provide best-in-class viewing experiences for audiences across the globe. And that spans a number of industries, not just sports, which we'll get into. So with that, I'll pass it on to the next slide for Bill and Derek to talk through a little bit about how the architecture works.
Awesome. Thanks, Kyle. Yeah, so as Kyle stated, that Teradek is bringing in the hardware side of this, either by direct encoding out of our Prism devices or bonding up to Core, which is our cloud platform. And from there, we can send that either WIP or RTMP out to the Phenix servers, where it's distributed throughout their 34 points of presence across the globe. This enables Phenix and Teradek both to have a sub-half-second delay and delivery of content from capture until viewership. Bill, do you have anything to add on the Phenix side on what
Yeah,
that?
I'll just add that this pairs nicely because wherever that encoder is located, it's going to be contributing to the nearest point of presence from Phenix, and then wherever the viewers are located, they're going to be connecting up to the points of presence closest to them. So it maintains the lowest last mile latency to give everyone the best experience.
And with recent changes and firmware updates in the Prism itself, we can actually deliver WIP from the device, so we can cut that latency down to as low as possible. So moving on. Next, I want to run through some of the Prism devices that we currently have that support this. From left to right, we have our desktop decoder and encoder, the Prism Flex. That is capable of sending 4K 60, either WIP or RTMP directly into Phenix or through our cloud service. We have the same architecture and the same technology, either in a 2U or a 1U rack format. So you can add up to 9 blades, 9 encoders, and 9 sources to a 2U rack and deliver all of those simultaneously over WIP to Phenix. Our Prism Mobile is actually a bonded cellular device, and the primary use case is field delivery, where we do have to send that up to Core first for the debonding service, so we can get all of those points bonded back together as a single stream, and then from there send that out to Phenix from anywhere on the globe, standing in the middle of the field or wherever your production might take place. And as an accessory to that Prism Mobile, the Prism Mobile currently has 2 cellular devices, cellular modems in it, either a 4G or a 5G modem. What we can do with the Prism Backpack, Prism Mobile Backpack, is add an additional up to 4 modems to that, so that you have more of a robust service coming out from wherever you're at. If you're limited on bandwidth, that will definitely help your signal get out and your contribution into Phenix from there. If you have any more questions there, please reach out to us at Teradek, and we'll let you know more information on that. Moving on, I did mention Core in this. Teradek Core is our cloud service. It's where the debonding and the signal dissemination actually comes into play, and that's where our hub is for the main points of ingest. From there, you can manage all of your devices remotely. So if you had a backpack or a Prism Mobile device in the field, you can change settings on the fly to adjust to whatever conditions that device is experiencing. And as we all know, it changes from place to place. So having a bit of control and over your devices remotely from anywhere in the world is a great option to maximize your connectivity. From there, also, you can monitor all of your input feeds, either live and do a live playback, so you can see the video frames themselves, or just manage them as a whole from a single pane of glass, if you have multiple devices online at the same time. And the final thing is distribution with Core. We can send to Phenix directly using Core, but you can also send this out and back to other decoders in the field if you have them in a NOC somewhere in your broadcast station, or if you need to just send a straight SRT or even a YouTube RTMP, you can do all of those simultaneously from Core. So it makes it a very seamless, integrated platform for anybody to control, monitor, and distribute everything from a single pane of glass. Moving on, we're going to discuss how the workflow looks running through Phenix. Bill, if you wanted to kind of expand on this.
Yeah, it sounds good. Thanks, Derek. Here we have a workflow chart going from left to right from the source, where we have a camera contributing a signal over SDI or HDMI to the Teradek encoder. In the demo I'll show you in a minute, we're using the Prism Flex encoder for this. And that takes the signal, encodes it, and sends it to Phenix over one of our supported protocols. In this case, we're going to be talking about and focusing on WIP, which is a WebRTC-based ingest protocol. That then goes into the Phenix network. You can think of Phenix as a media delivery network. So we have a global set of points of presence where we take signal in from one location and can route it and distribute it globally, maintaining the end-to-end latency and scale. After we get the signal, we're going to be doing a multi-bitrate transcode on the content so that we can have an adaptive bitrate experience for viewers, making sure that we give them the best signal quality and bitrate that we can for their dynamic network condition. And then we deliver that out to a wide range of devices. So WebRTC, being an open standard, is supported by most devices out there on the internet. And we're able to deliver directly into browsers, native applications, connected TV devices, all while maintaining all the things previous in the end-to-end workflow.
And the only one thing I would like to add is, although the focus of this webinar is real-time streaming at scale, we also have other egress options for more standard, higher latency streaming of HLS and MPEG-Dash. Together, we've worked to bring those latencies down, but we have a lot of flexibility both on the input side and output. So on input, as Bill explained, we can take RTMP, SRT, WIP, as well as a few other protocols. And on the output, we have the ability to deliver real-time at scale and also have HLS and Dash options for other use cases that customers may have.
Excellent. All right, moving on to our key customer verticals. See the ones that we want to discuss here, and primarily towards where Teradek sits right now are within the sports and the public safety, but we also work with Phenix in specific other verticals. And Kyle, if you'd want to talk a little bit more about what those are and how they look on your side.
Absolutely. I think the focus here is why do customers need ultra low latency or real-time streaming at scale? And that's to enable an interactive video experience. And that crosses multiple different verticals. And depending on the vertical, your needs for real-time may be slightly different. In live sports, it's about providing immediacy and enabling customers to do interactive gamification, interact with other viewers, potentially do sports betting. In the iGaming vertical, for example, you may have a live blackjack dealer in person at a physical table, but all the players are online. So you need as low of latency as possible and synchronization across the audience to level the playing field. In live auctions, for example, you have people bidding in person, competing with those bidding online. So in order to make that a fair and useful product, you need to be in real time and synchronized. In public safety, real-time and immediacy, I think, is self-explanatory, but is extremely critical. And it's important that everyone's getting that information at the exact same time. So those are a few select examples of industries where we're seeing a lot of traction with this type of technology that now is able to scale to larger and larger audiences. And from there, Bill will walk through some of the use cases of how these types of customers are using the technology.
The first use case is the most common one, being broadcast. You want to take a single video stream and deliver that out to a wide-ranging audience across the globe. And you want to do so with an interactive experience that's enabled by real time. So you want to be able to have users talking to each other, whether that's in band in the experience, out of band from social media, text messaging. And so with the combination of technologies here, we're able to deliver the high quality signal worldwide to all of the audience members and maintain their synchronization. So the kind of the two key things for interactivity are end-to-end latency, and that's so that you can have a host behind the camera talking to somebody that's in the audience and have a engaging experience because they're less than 500 milliseconds apart from each other. They can have that kind of back and forth. And also the synchronization of the audience so that everybody's seeing the same thing at the same time. And that way they can send messages to each other and they can say, hey, that was an awesome goal, or they can make comments on what's going on in front of them. And it's a coherent experience. Everybody sees that same thing at the same time. And the next use case is multi-view. And this has got kind of two main two main ways you can use multi-view. One is for multiple angles focused on the same piece of content. So you can have in a stadium, you'd have multiple cameras focused on the action, letting users select which camera they want to view the interaction from. And all those angles are synchronized. And so it's important because as something moves from one camera shot to another, you want to have that action be smooth and coherent across the different angles. And so these angles are delivered in sync, and you can switch between the angles and you'll see, the ball or the play move from one camera to the next seamlessly. The other kind of use case you can use this for is sort of multi-games. So you can have different games in the multi-view where you could have maybe different cameras on different golf holes or different tennis matches, things of that nature. We'll keep those in sync also. And so that if there's maybe some activity that or some commentary about the match as a whole, that makes sense across the different cameras, even if they don't overlap in terms of their field of view. And so this is a feature that's available from Phenix, and you can also build upon our building blocks to create your own customizations of this experience. In the next use case, we've got watch parties. This is small groups of people who may want to watch a piece of content together and interact with one another. So you may have a group of friends or a group of people with an affinity that want to join a session where they can have a video chat, like an online meeting, but with the main piece of content also being delivered into that experience. So you have the main match or the main interesting piece of content being delivered into an experience where you can have side chats, audio, video, and text side chats with each other, all enabled by the Phenix platform. So the main signal might be coming from a stadium through a Teradek encoder into the Phenix platform, combined with users' webcams talking to each other. So that allows you to have that kind of more social, interactive experience around the content.
And your last slide here, I believe, is going to be a live demo of the flex and latency. If you can explain what that is in layman's terms and how we're getting to that number, that'd be great.
I will. If you want to release the screen share, I will share the live demo version of it.
Okay. Awesome.
And so what you're seeing now on your screen is a demonstration of the end-to-end flow from camera to Teradek to Phenix to the web browser on my machine. So we've got a camera pointed at some content here, this laptop and the little entertaining thing on the left there goes over SDI into the Teradek Prism and is encoded. And when it's being encoded, the Teradek encoder is inserting timestamps, UTC timestamps into the H.264 SCI information field. That then gets sent to Phenix, in this case over WIP, and we ingest that, and then we take it from there and we do a multi-bit rate transcode to it. So we have multiple layers of content at different resolutions and different bit rates. And then we send that out over WebRTC to this browser here. And what you're seeing on the bottom are two lines, the top line being the time between when the Teradek encoder encoded that frame of video and when it's being displayed on the screen. And the blue line on the bottom is the time between when the Teradek encoder encoded the frame and when it's actually arriving in the browser. So the difference between those is the local sort of playout buffer, which is 33 milliseconds, which is about one frame of video. So there's only really one frame in the client buffer. And this is part of how WebRTC operates. There is a potential for a small buffer, in this case, one frame. And so we have an end-to-end latency from encoder to on-screen rendering of 300 milliseconds here. at 1080p, 30 frames a second. So you've got good quality. You've got the end-to-end latency, and this is really the key combination. This is Teradek plus Phenix equals high quality, low latency, end-to-end, at scale, and taking advantage of all the features that both companies offer.
Excellent. I love this. I love this chart and this view here, Bill. This is great. It's a great representation of how to show it. So,
Bill, was this for a full ABR ladder?
It is. So we have a multi-bit rate ladder from the top rendition at a high bit rate and the top resolution, and then we have a very sort of granular set of bit rate ladders and resolutions so that we can adapt to each user's individual network connection. So I happen to be stationary in an office, but if you're mobile and you're driving around and you're moving around and there's more different people in different areas, you're in a stadium, and we can adapt to make sure that everybody gets the best possible quality, maintaining the synchronization and the end-to-end latency.
That's very cool. I've seen lots of demos and where the results aren't actually something that's attainable by customers. Have we done anything here that would prevent a customer from getting similar results?
No, this is as I described it. It's camera to SDI, SDI to Teradek, Teradek to Phenix over WIP, and then standard Phenix delivery. Anybody with the Phenix and Teradek combo can get this. I've been really impressed with the Teradek encoder in terms of its quality and latency. I mean, getting down to 300 milliseconds end to end for 1080p is a great result.
Yeah. Also, is there a way to maintain sync between multiple cameras and the audio
Yes.
source?
Yeah, absolutely. So Phenix takes care of both audience sync for a single camera angle and multi-angle audience synchronization as part of our intellectual property, as part of the how we built our network, was to ensure we had the ability to deliver interactive experiences, and that's really one of the keys, is making sure we maintain synchronization across the audience, because otherwise, I mean, I have this experience. I'm a hockey fan, and I got a friend on the East Coast who's also a hockey fan, and if we're watching the same game, and our teams are playing against each other. Oh, that's a great goal! Like he's sending it to me. He's watching an over the air or sort of cable signal, and I'm watching it online, and he's telling me about it 45 seconds, a minute before I see it, right? And this is one of the problems that this solves is that'll just go away because we'll be watching the same thing at the same time. So he'll say something, I'll be seeing it, and we can have that kind of banter and back and forth that really is challenging, if not impossible today with the current, online, delivery stacks that people have.
Yeah, actually, speaking of like online and people watching broadcast or cable and online, and the discrepancy in latency over those. Another thing that there's a big discrepancy even today is ad insertion, right?
Mhm.
It's like you'll see an ad in the broadcast feed, and then in the online feed, maybe you'll see, oh, there's an ad break in progress. So
Yeah.
how
Yeah,
do we
thanks for the subtle
support?
reminder too. I mean, one of the other things that Phoenix is bringing to the table is server-side ad insertion, and that does allow for the ads to be inserted in the server side and delivered to all the audience personalized. So each person can potentially be getting a different advertisement from the ad decision engine, but it also prevents the kinds of things you see in a lot of the OTT sports video solutions right now. You'll see commercial break, hold on, right? A slate that just says, you've entered in the middle of a commercial break, and you're just seeing this slate, or the commercial content ends early and you have a few seconds of commercial, slate, and we can avoid that with the ability to do server-side ad insertion and do frame accurate insertion and frame accurate return, and not have to rely on the the chunk sizes and things like that. We can get it very accurate.
Yeah, another question that maybe a future thing, and that's as we look at the architecture or the workflow, we have the Prism Mobile either bonding up to Teradek Core
Mhm.
or directly into Phoenix, but not bonding directly into Phoenix.
Mhm. Yeah, that's something, that would be interesting to consider too. I mean, we haven't gone down that path, but certainly there's options there for, making that handoff even faster. Maybe even, with a cross connect or something like that versus having to have, us host the endpoint or, there's solutions there to take that little link, between the core and Phoenix and make it even more, performant or reliable. I mean, it's likely to work, you know, fantastic as is because they're both hosted in, well-provisioned data centers. But making sure that link is rock solid is something we could do as a follow-up as well.
One last question that I have, and it's kind of industry based. If I'm a customer and I'm looking at sub-second latency, I'm looking at scale. I mean,
Mhm.
typically there's scale, latency, and quality. Pick two of them,
Yeah.
right? And so, uh, as you look at the future, there's always something coming. And in the
Yep.
video space, it's typically the shelf life of any technology, whether it's hardware or software, is much longer than us in the industry would guess. There's media over quick,
Hmm.
live media protocol, and that's making a buzz in the industry. Where are we with media over quick? How does that apply to what we're doing today? And what are the thoughts of Phoenix in
Yeah.
moving forward on that?
Well, I mean, a lot of us here have been in the industry for quite a while. I used to work at Akamai Technologies in the CTO's office there in the media division, and saw a lot of things, a lot of developments in the industry, and that pick two out of the three. I call that sort of the iron triangle. You have three things you want to optimize for. As content went from traditional broadcast online, we were able to keep up with quality. There's more 4K HDR content online there is in the traditional world. The audience sizes, there's huge audience sizes now, tens of millions of people watching the single event, but latency was sort of left behind, and standard latencies are, somewhere on the order of 45 seconds or 60 seconds, 30 seconds, somewhere in that range, where traditional broadcast is always down in the, sub 10-second, range. And I just see that as a missed opportunity. And so that was one of the reasons why I joined up with Phoenix is, I saw the ability to kind of, I want to say break or maintain, the iron triangle and have all three. You can have high quality, you can have, broadcast scale audiences, and you can have, low latency. And, the question was, what's the thing you get out of lowering that latency, and where are those breakpoints, right? And as you get down to real-time latencies, you gain interactivity, you gain the ability to have people have, interactions, conversations. And I think that's important as, more and more information is coming out about people watching like a sport event. They're sitting on their couch and they're kind of leaning down or leaning sideways, looking at their phone, doing things, whether it's social or, secondary experiences, and they're disconnected from the main content because they're probably happening, faster than the content is getting to you, whether that's, a message with your friend, or maybe that's in some areas where you can have sports gambling. You've got, those opportunities, you get data feeds coming in that are coming in, in real time. And so, this platform is really, sort of built for that interactive future that we, I think, all can see kind of coming our way.
Yeah, a couple more things before we wrap up. Question from Norm. Is the viewing experience browser-based only?
No, we can work anywhere where there's a WebRTC stack already built in, or where there's the ability to have a native library. We have our own WebRTC implementation that we have in an SDK that we can provide, and very often gets incorporated into our customers' iOS apps, their Android apps, their Apple TV apps, any platform where you're building native code. We've got this core library that we provide that provides that WebRTC stack if it doesn't already exist. If the platform has it built in, whether it's a browser or some other web-based, CTV platform, then, we can leverage that WebRTC stack that's there. So we can do either one.
And from the Teradek side too, I want to add, we are sub-second from encoder to decoder as well. So if you need to have traditional broadcast receive on the far end, SDI, HDMI, that sort of input, we're doing the same sort of timing between our encoder to decoder as well.
Okay, thanks for that. And so to wrap up, NAB is another question in the chat. Teradek will be there as part of our parent company Videndum's booth. in the North Hall. Will Phenix be there?
We will. We will be there in person, and looking forward to seeing everybody there at NAB. Look us up.